This is Dr. Carroll with another graphs video. So it's about Thanksgiving time and you're getting ready for a large crowd for your feast. So that everything gets done in the right order on that big day, you've made a graph of the dependencies, or you've listed them all out and you said, that looks a lot like a digraph here. And so you've got it all listed out, but what you want to know is what order to perform all of the tasks. You wonder, is there a digraph algorithm to give a linear ordering to all of the nodes? Well, not surprisingly, there is, and it's called topological sorting. So the definition of a topological sorting is if you're given a graph that is directed, a digraph, and there's no cycles, so an acyclic digraph, G, with vertexes V and edges E, then the task is to find a linear ordering of vertices such that for all the edges, V and W, that the pair there in our digraph, that V precedes W. Okay, now what does that mean? Let's look at some examples of some topological orders. So here's an example of a topological order where we prep the stuffing, then we prep the bird, bake the bird, make the gravy, prep the potatoes, bake the potatoes, prep the yam, bake the yam, and then say grace. We're all done. If you did the tasks in that order, you would have had done everything in the right order and everything would be done. But what if you wanted to rearrange some things? Maybe you're going to prep the bird before you prep the stuffing. Now, people don't recommend that anymore. It's a lot safer, so just bake it on the side, and that'd be better. You may want to get started real early the day before, early in the morning, and prep everything, then bake everything, and then say grace. And so there are multiple topological orders for this given digraph. And so really, one way to think about it is that any linear ordering of all of the vertices in which all of the arrows go to the right is a valid solution. If you'll notice in those previous topological orders, all of the arrows went to the right. Okay, that's great, but now what about an algorithm to solve it? So if we had a method we'll call toposort1 in a digraph class, it's going to return a list. That's our topological order. Okay, so that's what we're trying to achieve. First thing we do is we make a copy of the digraph, and so that we can work with it, as we're going to remove edges and vertices from it. Then we make an empty list that we're going to return, and for the same number of vertices as we have, we're going to select a vertex, V, that has an out degree of 0. There are no edges coming out of it. Another way to say it is it has no successor. Okay, so we're going to find a vertex that meets that criteria. We're going to add that vertex to the front of our list. We're going to delete that vertex, same vertex V, and its edges from our copy of our graph, and then we're done. And there's the algorithm. Hope you've enjoyed this video. Check out my other video where I run through an example of the topological sort algorithm. That's it.